Every day, the world moves on as it always has. Cities wake up, work begins, and life feels familiar. But beneath that sense of normality, something is shifting. The climate is changing, and the systems we rely on, energy, food, water, cities, finance, are under pressure in ways we're only beginning to understand. These changes don't live in reports or projections, they are already shaping people, livelihoods and communities. We created the Climate Leadership Podcast so these challenges don't remain abstract or distant, but are explored through the people working inside these systems, making real decisions with real consequences, often without clear answers. This is not a space for fear, blame, or perfection. It's a space for honest conversations about what leadership looks like in a changing world. If you're listening, you're already part of that leadership. Let's begin the conversation.
Welcome to another episode of the Climate Leadership Podcast. Today's conversation focuses on one of the most powerful yet often underestimated climate solutions available to us, which is energy efficiency. At a time when energy systems are under pressure from rising demand, geopolitical uncertainty, and climate risk, efficiency offers something remarkable. It can deliver faster results, lower cost, and fairer outcomes all at once. Joining us today is Mr. Will Atkinson, Senior Associate at RMI. Will works at the intersection of research, communication, and partnership-driven policy projects, helping accelerate climate and energy solutions that provide rapid benefits both globally and locally. His work spans peer-reviewed research, executive-level strategy support, and real-world policy engagement. In this episode, we will explore why energy efficiency is not just about reducing emissions, but also about improving public health, strengthening grid reliability, lowering energy bills, and advancing energy equity. We will also discuss why the current moment presents a unique opportunity to scale these solutions. Thank you, Will, for joining me today on this podcast.
Thank you, Amber.
So as we begin, can you please introduce yourself for our audience?
Sure. Well, you just did, so there's not much more for me to say. But I'll just briefly say that I came from this from a very climate angle. I did a lot of climate change research in university and in graduate school. But I realized that in the current times, it's more important than ever to talk about benefits beyond climate and to focus on underappreciated solutions that many people may not be aware of how powerful they can be. And so that's why I'm really looking forward to focusing today on energy efficiency.
Perfect. So let's get started. To begin with, when we say energy efficiency, what does that really mean today, and how has the concept evolved over the past decade?
Sure. So I think what's remarkable is what hasn't changed. 50 years ago, RMI's co-founder, Amory Lovins, coined this idea of soft energy paths towards like a stronger, safer future. He said that we don't really want combustion or electrons. What we really want is cold beer and hot showers. Now, I'm more of like a warm soup and warm tea person, but the great thing is that this idea is still true today no matter what we crave. Efficiency enriches our lives with more of what we want and less of what we don't. So that's the overall idea. I think it's important to keep that in mind as we take maybe a brief foray into wonkier definitions. So the classic metric for efficiency is this idea of primary energy intensity. And that means how many primary energy one uses per unit of GDP. Countries around the world set a global goal in 2023 to double the rate of annual improvements. And unfortunately, we've been going in the wrong direction since then. So it's not a very good news story. At the same time, some people think that the metric is flawed on both sides. Primary energy is weighted towards the inefficiency of fossil fuels. 2/3 of that energy goes up in smoke before it even helps anybody. And that's to the tune of $4.6 trillion per year or so globally. And on the bottom side of that equation, many have questioned whether GDP is the best indicator of the progress that we seek around the world. Regardless of metric, I want to get that bigger picture in people's minds. Efficiency means driving that progress more fully and fairly, and hopefully moving away from energy dependence towards more prosperous self-sufficiency.
Okay. So, Will, I'll just share with you what I understand from energy efficiency. So, for example, if we are burning a specific amount of coal, so the energy we get out of burning that coal, right? So, for example, if we can get 100%, but we are only getting 60%, so we are 40% inefficient.
Yeah.
So, is this the correct understanding of energy efficiency?
For sure. That's one way to look at it. And of course, in the case of coal, it's actually even worse. It's actually even more inefficient. But it depends on how you count that energy and how you count what's coming out of it. And what we try to do at RMI is to focus not just on making that coal plant more efficient in the micro level, but thinking more broadly about the system, about the macro level, and how we can make the overall energy system more efficient to avoid those inherent inefficiencies in some technologies.
Okay, sure. So energy efficiency is often described as the first fuel. Why do you think it still receives less attention compared to renewables and emerging technologies?
Yes. I talk about this question with my team often, and we call it the $1,000,000 question. It's a hard one to answer. But if I were to give another quote from Amory Lovins, our co-founder, he would say that energy is invisible, and the energy you don't use is almost unimaginable. There's this book called Subtract that makes this point well. The author, Leidy Klotz, says that the human brain is conditioned to add more and not as much to do less. And we see this even in many analyses in our space where energy demand is assumed to be fixed, and supply additions are the only option for what they're trying to solve, which is incomplete. But I think there's more to it also. I think energy efficiency means so many things in so many places, whether it's better building insulation or industrial motor upgrades or better design of cities. And each solution requires a whole different set of actors and actions to accelerate progress. It's a lot more multifaceted than just a single technology S-curve. But that said, this complexity could be a feature, not a bug. I'm hopeful that with more problem spaces, there could be more opportunities for more people, and more people can be involved in finding solutions. And that's the hope for the future.
Okay. So from your recent work at RMI, what evidence shows that efficiency can deliver faster and cheaper climate progress than supply side solutions alone?
Yes, when it comes to climate progress, going in on efficiency all the way, we think it could mean reaching net zero at least a decade faster. And that's from an article we wrote called Why Efficiency Matters, based on leading global research from groups like EASA and the IEA. But we can only maximize these benefits, again, if we look at the full system, not just that coal plant. Many folks do focus on more efficient widgets like cars or air conditioners, and of course that's crucial, but it's also crucially incomplete unless we expand our view. We can look, beyond the air conditioner to the full building in the house and how cool roofs can cut cooling emissions. We can look beyond the car or the truck towards optimizing the route that the truck drives, and that can help tackle trucking emissions. And of course, there's efforts like material efficiency in industry that can have benefits across sectors. And so you can find many of these examples in a different article. It's called What Efficiency Looks Like, that we've done recently as well. And this actually also goes beyond just carbon dioxide. Half of current climate change comes from methane and other superpollutants. And people like Project Drawdown call these emergency brakes because if we stop emitting them, most of their warming will be gone within a decade. And that's really important because we need to cut that warming fast. So solving them is the fastest way to cut climate change. And it turns out that efficiency is often the fastest way to solve those pollutants, especially in places like oil and gas and waste and cooling systems, where we have solutions that can cut costs now.
Right. So, Will, I was just thinking, can you share a bit about the term net zero? Like, how should I understand this term net zero? What does it mean?
Sure. Well, it's actually a little bit out of vogue right now, but the idea is that ideally we can have the net amount of carbon dioxide emissions, so the amount that we are emitting minus the amount that we're taking away from the atmosphere with things like carbon dioxide removal, that the net equals zero, that they're balanced. And that's required, honestly, to have a stable long-term climate or any chance of one, because if we don't, we're going to keep on having CO2 increase in the atmosphere. But of course, now, as we'll talk about in a second, there are many benefits beyond climate that we're hoping to emphasize in the coming years, no matter what people care about.
Sure, sure, sure. And also, just to follow up briefly, even though we reach net zero, for example, the earth will continue to warm up because of the carbon which is taken up by oceans, and because oceans take longer time to warm, so it continues to warm the earth even when we do zero carbon emission. So what do you think about that?
Yeah, I've actually looked at the science from people who are much better experts than I, and I actually see varying views on that. Some people say, like, there is baked-in warming, and some people actually think there's not. But no matter what you think, the fastest way to avoiding these impacts is to reduce emissions as fast as possible, and that's what I'm focused on.
Okay, perfect. So beyond emissions reduction, what are the most compelling, not climate benefits of energy efficiency, particularly in terms of public health and economic resilience?
Okay, well, there's so many, but you mentioned public health and economic resilience, so we'll start with those two. Yeah, so for health, air pollution kills more people every year than COVID-19 ever has, according to records officially, at least, that's around the world. The good news is that most of that comes from fuel pollution, which means that energy efficiency could hopefully save millions of lives every year if we did more of it. And that would make it one of the greatest health interventions we've ever had, which would be awesome. And the benefits would be strongest in places that need it most, whether it's places in South and East Asia or just other pollution hotspots around the world. And we've already seen success stories. We've already seen how people in China in some places have gained multiple years of lifespan just by cutting their coal emissions in part through efficiency. There's a lot of good progress to be made across the health spectrum there for air pollution, and of course other pollution in buildings that affects us inside the building as well. On the economic side, a big example there is the story of what happened in Europe after Russia invaded Ukraine. So as many of you know, gas prices there and around the world really got several times higher. Some countries like Pakistan got left in the dark completely. It was really bad. But of course, there was a surge in energy efficiency measures, especially in Europe. And 2/3 of the European gas savings that they made happened through efficiency. It wasn't through other technology switching. It was just because they had more efficient buildings and other programs. And that was crucial for helping their residents save money and, of course, save vulnerability from having to rely on foreign gas.
Right, right, right. So I think such events will put like a more consolidated pressure on the government to move from or to diversify their ways of getting energy, right, to be more energy resilient, right?
Definitely.
Okay, so in the current global energy landscape marked by energy security concerns and cost of living pressures, why is this a particularly timely moment for efficiency investments?
Well, it's like we just said, it's like the when Russia invaded Ukraine, but just on steroids now. It's a timely moment because efficiency helps to solve what everyone's worried about. For the first time in decades, pretty much every part of the world is facing growing demand, either for electricity or for energy more broadly. And of course, at the same time, there are tariffs, there are geopolitics concerns, there are natural disasters that are happening more frequently and really putting grid systems at risk. So everyone's worried about having to meet this growing demand. And that's especially true in many places with fossil fuels, because 3 out of 4 people globally live in fossil fuel importing countries. So it's a really big risk for them. Places like Ethiopia have banned combustion cars for that reason, because they rely on these oil imports. But of course, this is true across any technology. Any technology has a supply chain and has risks in that supply chain. So efficiency has this opportunity to avoid that reliance and move more towards self-sufficiency. And that's especially true in places that can build right the first time. So for example, India, we found that about 90% of the 2050 building stock is yet to be built. That's from RMI studies from the last couple of years. So it's amazing just how much building is going to happen in the next couple of decades. And of course, in the US and Europe, things are more built out, but there still is new demand for power, for electricity, that offers this opportunity as well. So if we can build these new systems efficiently, we can lock in decades of lower costs and more self-sufficient supply.
Right. Yeah, I think India is still on a developing path, and there's a lot of infrastructure development which is going on. And I think those are the numbers which you were saying, that a lot of construction is going to happen.
Definitely.
Right. Yeah. Okay, so how does energy efficiency strengthen grid reliability and reduce the need for expensive infrastructure expansion?
Yeah, great question. Again, flows right from the last one. It's a question that grid experts are grappling with across the world. And yes, it turns out that efficiency is often the fastest, cheapest way to ensure reliability across these grid systems. This has been showed in multiple research studies recently, whether it's the ACEEE in the US, whether it's the IEA around the world. And that's because if you add new supply, the parts and the permits and all the steps could take many years, whether it's offshore wind, especially in the US right now, whether it's the gas turbine supply chain crunch, and certainly whether it's nuclear and all of the steps that they've had to overcome. It's a little bit better for utility scale solar, but it's definitely still often years in many places. And it can be even slower for transmission, even though it is crucial to build out grids as well. So the fastest answers are the soft energy paths, whether that's grid enhancing technologies, whether that's distributed solar and batteries with virtual power plants, or just good old efficiency improvements like better appliances in buildings and industry. And so all of these help because it helps them get more out of the grid that they already have. They don't have to build as much new stuff. And of course, at the same time, because of that, these interventions are often twice as cheap, according to studies, whether it's from Efficiency Vermont in the US or even like the program in Brazil on efficiency. There are these examples all around the world that have been accumulated and compiled in these research studies. And it's really exciting to see just how big of a difference that makes if we can do efficiency first.
Right. Yeah. So, well, I was also thinking, so for example, we have a place A, which is generating the energy, and then we are transmitting it to a city B, where we are consuming that energy. So now losses happen at every step, from A to transmission to consumption.
Yep.
So every step we need to figure out more efficient ways to reduce this, right?
Definitely. And that's why at RMI, we really try to focus on the full system in mind. What you describe is true really everywhere, whether it's the gas distribution system or so many places, like especially with methane leaks as well. Methane can leak across that system and every part has a role. And sure, you could go one by one and try to fix these different leaks, and people are doing that, and that's important. And also, if you avoid the need for those gas systems entirely by having more efficient appliances, for example, you save all of those upstream losses and all of those costs that are associated with it.
Right. Yeah, that's very true. That suppose A, generation and this transmission is removed, and B, the city is directly taking renewable, for example, from the sun, the energy from the sun. So all these things are removed and only the B part leaves, right?
Definitely. That's why renewables are inherently more efficient, often 2 to 3 times or more efficient than their fossil counterparts. And of course, there's design things that can go even further, but both in parallel are very complementary and strong.
I see. Understood. Okay, great. So moving forward, one of the themes you often emphasize is equity. So how can efficiency policies be designed to ensure low income and vulnerable communities they can benefit first?
I'm really glad you asked this question. So maybe I'll tell a quick story about Pembroke, Illinois in the United States. It's a rural, historically Black farming community. and almost 1 out of every 4 families live below the poverty line. So it's a very poor community, and they never actually got connected to a gas line. So they've had to heat their homes with expensive and polluting wood and propane. On the good side, this makes them the perfect candidate for a project with RMI and our partners in the last few years to install more efficient home appliances and other measures for more insulated buildings and lots of different things for lower cost and higher comfort. They really avoided fossil fuel build out entirely, and they enjoy those benefits. And that's the case if we look all around us. There's so many examples of this, especially in places like I said before, that are building right the first time. So maybe it's efficient cooling systems that can help the billions in India, Indonesia, other countries where people don't have an air conditioner despite record heat waves that are only going to get worse. It's also the case for efficient transport systems, which give more access to mobility for the global majority who can't afford or own or drive a car. And it's the same thing for more efficient industrial plants, which often will affect the people who would otherwise suffer the pollution near them the most. It's the same thing to try to help be more equitable on that. So yes, if we start where vulnerability is highest, benefits can be greatest. It does require a lot of planning, a lot of thoughtfulness and community engagement, and RMI has some great resources on that. But it's very possible if we can do that right.
Right. So, Will, can you share how does RMI help such communities? Can you share a bit about RMI? I'm not too sure about it.
Sure. So RMI is a global nonprofit. We have more than 600 people who work globally. And so there's so many different teams that work on different things. But we try to work on these pilot projects and other projects at scale, both in the US and globally, especially now increasingly in places in the global south, such as India, Indonesia, Nigeria, other places where growth is happening quickly, and this could lock in more benefits. But it takes a lot of thoughtfulness to get there. It's a lot of work trying to unlock the bottlenecks that are happening. Often that's in finance, often that's in the policy measures. Maybe it's with the very nerdy but important utility regulations that can make or break whether a project happens. But oftentimes it's just in convening the right people. So oftentimes RMI acts as a convener to get the right folks in a room and unlock what people know is possible, but maybe hadn't considered or hadn't prioritized. And often, especially in this world of AI and noise and disinformation, it's really important to gather a person. And especially when you're trying to reach these vulnerable communities, it's really important to talk to them in person on the ground, or to be able to at least convene other people who do that as well. So we have this whole thing called the Energy Transition Academy, which tries to work to train people around the world in what's possible. And that's just one example, along with the projects around the world.
Okay. So, I'm just thinking, for example, I am a climate fund manager, and I want to do a green finance project in India. So can I approach RMI for their expertise? Does it work like that?
Yeah, it depends. But there certainly are projects that have done that. I would say, in your case of what you mentioned, 2 options would either be to try to approach people who work on the RMI team in that geography. So for example, we have a team that's based in Delhi in India. There are almost 30 people. It's some really strong work that often works with the government and other partners to deliver projects. So that's one option. The other thing I would say is we have these broader sector-based teams that work across geographies, but they have more expertise on that content. So for example, in the Global South, we have this program called Catalytic Climate Capital, which does try to allow for projects in the Global South, especially in electricity for clean energy. But of course, finance is the bottleneck, so they're trying to solve that, and that would be a good place to start in the case you mentioned.
Right. Yeah, finance is a bottleneck currently. Okay. Yeah. Okay, so moving forward, what role do businesses and industry play in unlocking large-scale efficiency gains, and what are the biggest untapped opportunities?
Ooh, there are many. So yeah, I think directing investment in the right places can be really powerful, actually similar to your last question just now. And there's a big disconnect between the biggest areas of opportunity and where investment currently is. So let's go both by sector and by geography. So in the case of sectors, almost half of energy demand growth in the near term is hopefully coming from industry, if the projections are right. That said, industry only gets about 8% of current investment. It's like a 5 times difference between the growth expected and the amount of investment they're getting. It's a very similar thing for regions. If we look at the global south as a whole, which of course is going to get more than half of growth in energy demand, but it's only getting about 11% of the investment right now. So again, a 5 times difference between the growth and the investment. If we can change that calculation, if we can have more investment going to these high growth places, and especially investment in efficiency to build right the first time, we can really have a huge impact on these systems. And in terms of how that looks like, I think there's a lot of cross-cutting examples, like with material efficiency, that can provide major dividends, especially when we're building out these systems. There are research studies like those from Stefan Polyuk and authors, which show that we can really, really have more efficient steel and cement and plastics and other systems in industry, especially in these places around the world that are growing fast, if we can double down on these efficiency measures for materials. And of course, that would help with your question earlier about security and supply chains, because if you don't need as many materials, you don't need to source as many and have these long, complicated supply chains that have all their impacts. And that would be really huge in this era of people wanting more self-sufficiency to have that as well.
Okay. Yeah. So, Will, I was thinking that you mentioned Global South, from where a lot of growth will come in the next 2 decades or 3 decades.
Yep.
But the investments are low.
Yeah.
So I think that people invest to get some return.
Right.
So what do you think about it, that there's low return from these Global South countries?
I don't think that's the full problem. And again, I'm not an expert on the finance side, but what I do know is that often there are other challenges, whether it's awareness, whether it's comfort in a local geography, or other factors that are beyond just the money itself. Okay. And oftentimes, there's just lack of understanding. And so one of the things that my team did in partnership with this group called Mission Efficiency is to build a global series of case studies of how energy efficiency can work and save money and provide good investment in the Global South across different countries, regions, continents, as well as sectors from buildings to industry to transport. And especially in the cases of appliances and more efficient industrial motors and systems, there are cases, whether it's India or Ghana or Brazil, that have saved billions of dollars across the years just from some simple changes in policy or incentives or investment from private sector. And so we're trying to show what's possible and hopefully inspire people to do more of that.
I see. So you're mentioning about a knowledge gap, understanding gap, which you're fulfilling with your case studies. That these are the areas which can be thought upon by companies, right, for investment.
That's the hope. And yes, this was led by a group called Mission Efficiency. We only had a small part in it, but it is very important to be able to spread the word and to show it's possible.
Okay, perfect. Okay, so from a policy perspective, what are the most effective levers government can use to accelerate efficiency adoption at scale?
Yes. So on the government side, I think standards are a really powerful lever. So it's funny because technologies have gotten better a lot faster than these standards. In the past 15 years, many markets have had their best available products, get 2 or 3 times more efficient than they were before. But in the case of the policy standards, that improvement is a lot slower. And the good news is that means there's a huge opportunity if we can match the policy standards to that progress in technology. So one key example is the air conditioner. According to the IEA, If every air conditioner bought since 2019 was the most efficient available, the world could have avoided the electricity demand growth as much as the same total global growth from data centers across that same period. So even just, more efficient air conditioners could have saved the entirety of demand growth from data centers over the last 5 years or so. And we've seen at RMI some really powerful results in India that demonstrate what's possible. RMI and its partners did 9 months of field testing with these so-called super efficient air conditioners, technologies that won the Global Cooling Prize a few years ago and are often 5 times more efficient and less climate warming than the standard products on the market today. And so when we tested those in the real environment, we saw that these air conditioners could save at least half of the appliance's energy use, also cost to households, also contributions to peak grid demand, all of these benefits. And in many cases, the bottleneck is the policy standards. It's especially the need to align the standards to the fact that we don't just feel hot because of temperature, we also feel uncomfortable because of humidity. Humidity is a big factor in cooling us and in making air conditioners efficient. But standards don't take into account that humidity. And so if they did, they would really incentivize these superior products and probably save trillions in the years ahead if we switch to them. But again, it's that policy standard bottleneck that's happening. And so I think governments have a big role to play in that. And there are trainings from the IEA and other places that can say much more about what's possible.
Okay. So, Will, I was thinking that you mentioned like refrigerator, or you took the example of air conditioner, right?
Yeah.
So what I think is like electronics is developing really fast.
Yeah.
There are more efficient chip manufacturers. So when those chip goes into these air conditioner, it becomes more efficient.
Mm-hmm.
And many of the household appliances are becoming more efficient.
Yeah.
Now, so because of the policy, people are not buying that, or what is happening?
So oftentimes these newer technologies that are superior are, they're not, like it takes them more time to enter the market because of these standards, or these standards are not fully showing how much better these new products are. So so we talk at RMI about 5 phases of adoption of technologies, like from the very early R&D to mass adoption.
Yes.
And especially in these technologies like these super efficient air conditioners that are in phase 2 or 3 out of 5, like they're just getting started, they're getting commercialized, but they need some more early adoption, they need some more market uptake. That's the point where policy really can play a big difference, because if they can make it more standard to switch to these new products, if they can incentivize the mass market build out of them and supply for them, then that really can take off, and then the market can do its thing after that.
Understood. So if the policy shifts, then within a week or within days, you have to shift to the new technology, right? So it will be faster. The adoption will be faster.
Yeah, the details depend on the policy, but for sure it can speed up adoption.
Right. Okay. So well, finally, looking ahead 5 to 10 years, what would success look like if energy efficiency were treated as a central pillar of climate and energy strategy?
Yes, that's a fun question. We've actually been thinking about 50 years because it's the 50th anniversary of that soft energy pass concept. So stay tuned for more to come on that. But for 5 to 10 years, I think it's fun to actually look behind us first at what's possible, to look ahead as well. So I think back to a city like Paris, France. Just a decade ago, there was all of this gridlock from cars, but at the same time, there was some really bold policy in the last 5 to 10 years, which enabled more efficient transport options really fast, and it changed things really fast in the city. And so now, for example, bike trips outnumber car trips, not just in the urban center, but also in the inner suburbs of Paris. It's a really big range where bike trips, even in like a morning commuting hour, can be 3 to 1 over how many car trips there are. So it's really possible to change systems fast. It just takes boldness and making it happen. But the impact could be huge if we can do this across the fastest growing cities in the world. People in the international science community think that just efficient city design alone could save maybe as much as 1/3 of global transport emissions by mid-century. So there's a lot of potential. But again, there's many benefits beyond climate as well. So I'll wrap up with a story from myself. So I am lucky to live in Boulder, Colorado. And actually, I grew up in Rhode Island in the US, and I never learned how to ride a bike because it was a suburb, there weren't many bike lanes, it just didn't make sense, it was really hard. And so, I was kind of sad that I never learned how to ride a bike, but then around college age, I learned how, and part of that was because there were better designed places that I was living where it allowed for bikes and made it more possible to do that. Mm-hmm. And so now I live in Boulder, and I can pretty much go without a car anywhere in the city, whether it's by bike or by bus or walking or anything else. And I just feel healthier and happier. Like, it's just nice to be able to get around outside, moving my body, and there's more freedom as well. There's less traffic. There are fewer other concerns. I don't have to park as much. There's all these benefits not having to have this. So I'm hopeful that a future, of course, it'll take time, but in the next 5 to 10 years, we can have more examples of building right the first time, of having these more efficient, smart cities and other design across our systems from building to transport. And that means more choice and more freedom for all of us.
Right. Perfect. So thank you, Will, for such a thoughtful and forward-looking conversation. And thank you for sharing that story. It's a really powerful message, what we can achieve, by changing some small levers, right? So this discussion is a reminder that energy efficiency is no longer a secondary climate measure. It is central to solving today's energy and economic challenges. Decisions about infrastructure, investment, and policy increasingly depend on recognizing that efficiency can reduce emissions, which are quickly lower cost, strengthen energy security, and deliver meaningful public health and equity benefit. For leaders, policymakers, and businesses, efficiency cannot be treated as an add-on. It must be embedded within the strategy, planning, and long-term decision-making to build faster, cheaper, and fairer energy system. Thank you for joining us on the Climate Leadership Podcast. We will be back soon with more conversations. Until then, take care and have a nice day. Bye-bye.